Good morning, students. Today we are going to represent Phasor representations of alternating quantities. The alternating quantities are represented by phasors. A phasor is a line of definite length rotating in an anticlockwise direction at a constant angular velocity omega. The length of a phasor is equal to the maximum value of the alternating quantity, and the angular velocity is equal to the angular velocity of alternating quantity. So we have to consider a small circle of radius OP. So we are taking the OP is nothing but the maximum value of current so the maximum value of the sinusoidal quantity is Vm. Here the OP will be considered as Im. Here the y-axis quantity is current and x-axis quantity is equal to theta. Where Im is the maximum value of the alternating current, let this phasor rotate in an anticlockwise direction. So at a uniform angular velocity of omega radians per second. The projection of the phasor O to P on the y-axis at any instant gives the instantaneous value of that alternating current. So phasor diagram using RMS value. Sinusoidal alternating currents and voltages can be represented by phasors. Electrical measurement instruments like ammeters and voltmeters are calibrated to read the RMS value of AC quantities. Hence, instead of using maximum values, it is more convenient to draw phasor diagrams using RMS value of alternating quantities. However, such a phasor diagram will not generate a sine wave of proper amplitude unless the length of the phasor is multiplied by root 2. Consider the problem. Two currents I1 and I2 are given by the expressions I1 is equal to 10 sin omega t plus pi by 4 and I2 is equal to 8 sin omega t minus pi by 3. Find the first question is I1 plus I2 and the second question is I1 minus I2. Express the answers in the form small I is equal to Im sin omega t plus or minus pi. So I1 is equal to 10 sin omega t plus pi by 4 and I2 is equal to 8 sin omega t minus pi by 3. Let phases I1 and I2 represents the alternating currents and small I1 and I2 respectively in terms of their maximum values. So in the analytical method, by solving I1 plus I2, resolving I1 and I2 into x and y components, here we are having I1 is at an angle of I1 is equal to 10 at an angle 45 degree and I2 is equal to 8 at an angle of minus degree. By adding I1 and I2 we are getting 11.07. At the y coordinates 10 sine 45 plus 8 sine minus 60 is equal to 0.14. So magnitude of I1 plus I2 is equal to square root of summation of x square plus summation of y square. 11.07 whole square plus 0.14 whole square. So the resultant value is 11.07. Now we calculate the phase angle pi, that is tan inverse of summation of y by summation of x. So tan inverse of y value is 0.14 and summation of x value is 11.07. The answer is 0.72 degree. So I is equal to I1 plus I2 is equal to 11.07 omega t plus 0.72 degree. So graphical method, the phasor sum I1 plus I2 is obtained by adding phasors I1 and I2 by the parallelogram. Now let us discuss the second analytical method, that is I1 minus I2 into x and y components. So we are adding I1 at an angle of 10 at an angle 45 degree and I2 is in the y axis. So summation of x is equal to 10 cos 45 minus 8 cos of minus 60. that is 3.07. Then summation of y is equal to 10 sine 45 minus 8 sine of minus 60. It is equal to 14. So magnitude of I1 and I2 is equal to square root of summation of x square plus summation of y square. That is square root of 3.07 whole square plus 14 square is equal to 14.33 ampere. Phase angle pi is equal to tan inverse of summation of y by summation of x. That is tan inverse of 14 by 3.07 is equal to 77.63. So I is equal to I1 minus I2 is equal to 14.33 sine omega t plus 77.63. Graphical method. The resultant current has been drawn between I1 and I2. The phasor sum I1 minus I2 is obtained by adding phasor I1 and minus I2 by the parallelogram. It has been shown in the figure. Thank you.